What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 12 in the 7th grade math questions that North Carolina released this past school year. The question tells us that Kevin is paid $8.80 per hour, and I've gone ahead and pointed out that per means multiplies, along with the word each or the word every. So we'll be multiplying the hours he worked times the money he made. And if he worked 7 hours, then I've already gone ahead and said that that's 7 times 8.80 times $8.80. He gave his mother 1/4 of his earnings, and we're supposed to figure out how much Kevin had left. Now, I've pointed out another couple keywords. If he gave his mother 1/4 of his earnings, we're supposed to figure out how much he had left. Those two words together tell me that I'm going to have to do some subtracting at some point. So, in order to do a question like this, the biggest skill, we are going to do some subtraction, but we're going to have to multiply decimals, fractions, and whole numbers. We're going to be working with all three in this question. It's a bit of a doozy, but we're going to work through it. So let's go ahead and start with this 7 hours at $8.80 per hour question. And let's go ahead and just do some multiplication in order to figure that out. I'm going to go ahead and use the standard way. I'm going to put a decimal there, and then I'm going to kind of ignore it. I'll bring it down near the end. But I know that if my numbers had exactly one decimal place for the 0.8 or the 8/10ths, let me just erase that, then my answer is going to have one decimal place, but we'll go ahead and figure out all those numbers first. So if I'm doing 88 times 7, ignoring my decimal just for right now, I start with 7 times 8. I can remember from my times tables or use some skip counting or something like that to say that it's 56, also known as 6 ones and 5 tens. I do 7 times 8, and that's 56 again. I add my 5 tens from the previous quick little multiplication problem to get 61. So that is a total of 616, which means I put a decimal down. I make sure to add my 0 because I'm thinking of this in terms of money, and that's $61.60. So that's his earnings. And now, there's actually, at this point, two ways that we can solve this problem from here. Because essentially, if I want to take the information in this section of the problem and translate it into a word sentence that I can later use with some numbers, that's essentially going to be all of his earnings minus the 1/4 he gave to his mother equals how much he has left. And if I think of all as just 1 is another way of saying 4/4, and that's kind of blocked out by these words, but take my word for it, this is 4/4. 4/4 minus 1/4 gives me 3/4. So there's two ways to do this. We can just figure out what 3/4 of this 6160 is, or we can figure out what 1/4 of 6160 is, and then do some subtraction. And I'm going to go ahead and do this problem both ways from here. So for that, I'm going to have to use the magic of editing to get out my big board. So let's get started by figuring out what exactly 1/4 of this 6160 is. And once again, I'm going to ignore my decimal. I'll just know that my answer has to have 2 decimal places. I'll go ahead and write it like this. 6160 times 1/4. And whenever I see a problem like this, I'm going to instinctively say this is 6,160 ones or 6,160 wholes or something like that. Again, we're just ignoring this decimal until we are done with the problem. I do some multiplication across my numerators and denominators. 6,160 times 1 gives me 6,160. 1 times 4 gives me 4. And now I need to translate from fraction language to division language and say that 6,160 over 4 is the same thing as 6,160 divided by 4. And like with every long division problem, I'm just going to say that if there's another way that you know how to do a problem like this, go for it, try it out. You can even send me an email explaining or giving me a video of your method. So to start with, let's see how many times 4 goes into 6,000s. 4 goes into 6 one time. Cool, and we get rid of 4 of those thousands. We're left with 2 thousands. I bring down the number in my hundreds place, and this is essentially 21 hundredths. So now I'm seeing how many times 4 can go into 21 hundredths. Now I'm kind of going to need my times tables here. 4, 8, 12, 16, 20. So 1, 2, 3, 4, 5, too many. 4 is going to go into 21 5 times. We get rid of the 20 hundreds that we would need. We're left with just 100 after that. We bring down our tens. So now we're looking at 16 tens. So the question is now, how many times does 4 go into 16? 4 goes into 16. 1, 2, 3, 4 times exactly. So this leaves us with 1540. I put back that decimal that I decided to ignore to make this problem a bit easier, and it gives me $15.40. So this dude, I forgot his name already, is giving $15.40 away to his mother. So it's at this point that I just need to figure out 6160 minus 1540. I will ignore my zeros because they'll just give me a 0 anyway. So now let's go ahead and do this subtraction. So 6 tens minus 1 10 is going to give me 5 tens. So that's the same thing as 51 minus 5, but I can't really do this because 51 ones minus 5 ones is actually going to give me 46 ones. Now that I'm done with all this stuff, I'm just looking at my tenths now. 6 tenths minus 4 tenths gives me 2 tenths, leaving me with 46/20. And again, with subtraction, same thing as division. If there's another way that you know how to do this that you think is easier or just better to work with for you in the way that you think, by all means go for it. If you do it correctly, you should still get $46.20, which is our answer. But now I'm going to do it the other way, where I'm going to say that since the amount of money that this kid has left, right, his name was Kevin. Kevin has 3/4 of his original money left. So I'm going to say that we can get the same answer by doing $61.60, or 6160 times 3/4. Alright, so now I'm going to start with the same process. Put this over 1. I multiply across my numerators and denominators. 6,160 times 3. I need to figure that out. 6160 times 3. Nope. I am moving that 3 because it makes it easier to deal with. Just bring that 0 down. 3 times 6 is 18, also known as 8 ones and 1 10. 3 times 1 is 3 plus 1 is 4 tens. And finally, to finish this multiplication problem off, 3 times 6 is just 18. So we end up with 18,480. So this gives me 18,480 divided by 4, or 18,480 fourths. At this point, we just need to do some more long division, so I will go ahead and set that up. 18,480 divided by 4. Once again, I'm ignoring this decimal place. So I'm going to see how many times 4 goes into 1 10,000. The answer is no time, so I put my dot up there to remind myself that I tried that number already. I move on to my 18 thousands, and 4 goes into 18 4 times. We take out that 16, and we're left with 2. So this is 2 leftover thousands. I bring down my 4, and this translates now to 24 hundreds. So now I'm seeing how many times 4 goes into 24, and that's 1, 2, 3, 4, 5, 6. That's 6 times. 24 is even, so that's fine. And now I'm just comparing 4 to 8 tens. 4 goes into 8 2 times. I put my 0 at the end, and we still get $46.20. So either way, we got the same answer. And at this point, I just need to draw it into my gridded response. Now, I'm going to give... When I do a gridded response question, I need to give each digit and my decimal place 1 space. And below my 4, I need to actually find my 4 bubble and bubble that in, my 6 bubble and bubble that in, my decimal point bubble and bubble that, my 2 bubble and bubble that, my 0 bubble and bubble that in. So that is how we solve and answer and put in the graded response section a long problem like this.